The discovery of Oumuamua, the interstellar object that passed through our solar system, has sparked an incredible amount of speculation and debate within the scientific community. When it first appeared in 2017, its elongated, cigar-like shape and rapid speed immediately drew attention from astronomers around the world. Unlike typical asteroids or comets, Oumuamua displayed several unusual characteristics. Its strange behavior led some to propose a bold theory, that it could be a probe sent by an advanced extraterrestrial civilization. After all, how often do we encounter objects from outside our solar system? Yet, as much as some would like to believe in the possibility of alien origins, the truth might be more complex, and equally fascinating. Oumuamua's interstellar journey has puzzled astronomers. Its trajectory revealed that it came from outside our solar system, traveling at a velocity much greater than any known comet or asteroid in our local neighborhood. However, despite its remarkable speed, we were only able to observe it for a brief time. Its appearance, size, and exact composition remain elusive. The mystery of its shape, resembling a flattened cigar or perhaps even a thin needle, has confounded many. To estimate its size, scientists have to rely on indirect observations. By measuring its brightness and understanding how comets and asteroids reflect light, they can make educated guesses, though the object's true dimensions remain an enigma. One of the most intriguing aspects of Oumuamua is that it doesn't display the characteristics typical of a comet, such as a visible coma or a tail of gas and dust. Comets, as we know, tend to release material when they approach the Sun, forming these tails due to the intense heat and solar radiation. Yet, Oumuamua didn't follow this pattern at all. Even more perplexing is its rotation. Rather than tumbling in the way many natural objects in space do, it spun at a constant rate that seemed entirely out of place. Scientists couldn't ignore the fact that this behavior didn't align with the physics of most known space objects. These anomalies prompted some to wonder, could Oumuamua be something more than just an asteroid or comet? Could it be something artificial? Adding to the mystery, Oumuamua seemed to experience an unexplained acceleration during its passage. Unlike typical objects in space, which follow a steady path governed by the Sun's gravity, this object accelerated in a way that couldn't be explained by gravity alone. Some scientists proposed that this acceleration might be due to solar radiation pressure, a force exerted by sunlight. If Oumuamua were an extremely thin object, like a sheet of paper or even a light sail, it could experience a push from sunlight strong enough to alter its trajectory. This theory aligns with our current understanding of light sails, which are devices that use the momentum of photons to propel spacecraft. The concept of light sails isn't entirely new. NASA's NanoSail D2 and Japan's Icarus mission have demonstrated this technology, and scientists believe that in the future, these sails could propel small spacecraft to other stars. If Oumuamua were indeed a light sail, it would mean that it could travel across vast stretches of interstellar space, propelled by nothing more than the momentum of light itself. Its estimated journey from its parent star system is believed to span at least 16,000 light-years, a staggering distance that makes it a valuable object of study for researchers trying to understand the dynamics of interstellar travel. But what exactly is Oumuamua? Is it merely an asteroid ejected from its star system, a comet from another solar system, or is it something far more exotic? Perhaps it's a probe or an object deliberately sent out into the cosmos to explore other worlds. One thing is for certain, Oumuamua has certainly sparked more questions than answers, forcing us to reconsider how we approach objects from beyond our solar system. Could we encounter more such visitors in the future? If Oumuamua is part of a random population of objects ejected from other stars, our solar system might continue to receive similar objects. Understanding the origin of Oumuamua is a challenge, however, as it's moving along a path that aligns with the local standard of rest, essentially the motion of objects in our region of the galaxy. This makes pinpointing where it came from all the more difficult. If there's one frustrating aspect of studying Oumuamua, it's that it's already long gone. Its high velocity and trajectory have made it impossible for conventional spacecraft to catch up. But just because we missed this opportunity doesn't mean the door is closed on future interstellar exploration. Initiatives like Breakthrough Starshot, a bold project aimed at sending small, light sail-powered probes to nearby stars, could provide humanity with the tools to study objects like Oumuamua up close. With the right technology, we could send probes across interstellar distances, perhaps even within our lifetimes. In the meantime, studying the object's brief appearance in our solar system offers a glimpse into the possibilities of future space missions. Now, imagine a future in which humanity constructs its own shipyard, not on Earth but out in the distant reaches of our solar system, perhaps near the asteroid belt. This would allow us to build spacecraft capable of venturing far beyond the planets, ready to explore objects like Oumuamua. However, creating such a shipyard would require not only tremendous resources but also a deep understanding of the universe, especially the most mysterious force in modern science, dark energy. Dark energy, which makes up a majority of the universe's energy content, remains one of the greatest unsolved mysteries in astrophysics. If we ever want to harness it for propulsion or other technologies, it will require a massive leap in our scientific understanding. The potential of dark energy could enable interstellar travel on a scale we can only begin to imagine. One exciting concept that could change the way we think about space travel is the theoretical idea of a wormhole. Wormholes are essentially shortcuts through spacetime, proposed by Albert Einstein and Nathan Rosen in the 1930s. These cosmic tunnels could, in theory, connect distant parts of the universe, allowing us to bypass the vast distances that separate stars. However, despite the intriguing possibilities wormholes present, there's still no direct evidence of their existence. Scientists speculate that wormholes could form around massive cosmic objects like black holes, but without empirical proof, the concept remains in the realm of theory. Even if they do exist, the biggest question is whether they could ever be stable enough for travel, and whether we would even be able to detect them. If wormholes can exist, they could provide an entirely new way to explore the universe. But even if wormholes are far off in the future, there's another idea worth considering: the warp drive. This concept, also often seen in science fiction, would allow a spacecraft to travel faster than light by distorting spacetime itself. While warp drives have not been realized, research into this area continues. Theoretical models have shown that it might be possible to create a warp bubble, enabling a spacecraft to bypass the light speed limit. Of course, the challenges of creating such a technology are monumental, and we're nowhere near being able to build a working warp drive. But imagining a future where humanity can warp through the cosmos opens up a world of possibilities. The road ahead for space exploration is incredibly exciting. Whether we are investigating mysterious interstellar objects like Oumuamua or delving into the uncharted territory of wormholes and warp drives, the future promises an adventure like no other. While we may not have all the answers yet, our innate curiosity and drive for discovery ensure that we will continue to push the boundaries of what is possible. Perhaps one day, the answers to the mysteries of the universe will be within our reach, if we dare to venture into the unknown.